Welcome to the deep dive. We're all about getting a handle on complex topics without getting totally lost, right? And today we're taking a deep dive into some nomadic field notes.
Yeah.
From March and April.
Yeah, March 26th and April 9th, to be exact.
Right, right. Thanks for that. And these notes deal with this ontological hierarchy and topos framework. Pretty heady stuff.
Definitely. It's based on this document called OARC 104 2025 04-08.tex.
Okay, so we've got this dense material, and what we're going to try to do is unpack this framework, see what it says about reality, and get to the core takeaways, without getting too bogged down in all the academic jargon.
Exactly. There's some really profound stuff here.
So let's just jump right in. What's the first thing that grabs you about this framework?
Well, the first thing that really struck me was the idea of a two-layered structure of reality.
2 layers. Okay, I'm intrigued. Break that down for us.
So we have the implicate topos. We can call it I for short. This is kind of like the realm of pure potential. Everything is interconnected through what the notes call coherent alignments.
Coherent alignments, huh? So like everything is linked together in some fundamental way.
Precisely. Now, mathematically, they describe it as an autopos, which sounds really abstract, but just picture it as a space with like infinite layers of connection, just this incredibly complex network. And really, the point isn't the math itself, but this idea of deep inherent interconnectedness.
Yeah, okay, I can sort of visualize that. So what populates this implicate topos? What's in there?
Well, inside this topos, you have these things called non-Hausdorff phase spaces.
Non-Hausdorff. I'm already feeling a little lost.
No worries. It's a fancy way of saying that these distinct states of being, they can kind of overlap or have this inherent connection with each other. They're not completely separate. And then you have the relationships between these states called morphisms.
Okay, so connections between these overlapping states, what do those look like?
The notes describe them as resonance conditions. So it's like these states are vibrating together, resonating with each other in this implicate topos.
I'm starting to get the picture. This implicate topos is like this buzzing network of potential with everything interconnected and kind of blurring together. But then how do we get to the reality we actually experience? The trees, the stars, even this podcast studio.
Right. That brings us to the second layer, the explicate topos, which we can call E.
Okay, so I for implicate, E for explicate. Got it.
Yeah. And the notes describe E as a Boolean localization of I. It's like you're taking that blurry, interconnected image of the implicate topos and you're sharpening it, focusing it down to create distinct, separate objects.
Like turning a fuzzy picture into a high-definition one.
Exactly. The explicate topos is our everyday reality, the world we can observe and interact with. It's the world with clear boundaries and distinctions. What's really interesting is that the notes say it's generated by QFT plus GR as boundary condition.
QFT and GR, so that's quantum field theory and general relativity. Those are some pretty heavy hitters in physics.
Absolutely. What it suggests is that these fundamental laws of physics act as the rules, shaping this observable reality from the underlying potential of the implicate topos. They're like the boundaries that define what's possible in our everyday world.
Okay, that makes sense. So we've got this underlying implicate topos and this more defined explicate topos that we experience. But how do we get from I to E? How does that transition happen?
The notes talk about something called a projection map, denoted by Offer. It's the process that unfolds aspects of that underlying interconnectedness from the implicate topos into our more defined reality.
Like shining a light through a prism and splitting it into all the colors?
That's a good analogy. It takes that unified potential and unfolds it into the multiplicity of things we see in the explicate topos.
I like that. So there's a process that projects from I to E, but does everything from I make it through? Does everything get projected?
That's where things get really interesting. There's also this concept of the kernel of kernel.
What's that all about?
Think of it as the lost information. These are aspects of the implicate topos that don't make it through the projection into our explicate reality.
So some things get left behind in the transition. What happens to that lost information? Does it just disappear?
We don't really know. It's kind of a mystery. But the key point here is that the notes explicitly state that Math frecked up, which is a fancy mathematical way of saying that the kernel is not empty. There is information being lost in this projection.
Wow, that's mind-bending. So there are parts of this deeper fundamental level that we just can't access in our everyday experience. And that leads to the key theorem mentioned in the notes, right?
Exactly. The theorem states the projection Fingerea-Della is non-surjective. It's a technical term, but basically it means that this projection map doesn't capture everything from the implicate topos and the explicate topos.
So it's not a perfect, complete translation. There are gaps.
Precisely. And the notes go on to say that this theorem highlights the fundamental incompleteness of our observable reality.
So we're only getting a partial view, a filtered version of what's really out there.
It seems that way. This deeper implicate order holds aspects that might never be fully grasped or manifested in our reality.
That is a huge thought. It really makes you question what we're missing out on, what's beyond the limits of our perception.
Absolutely. And I think that's one of the most profound implications of this framework.
So just to recap, these nomadic field notes are pointing to a reality that's more complex than we typically imagine.
Yeah.
We have this deeper interconnected level, the implicate topos, and our familiar world, the explicate topos, is just a partial projection of it. And that projection isn't perfect. Some information gets lost along the way.
That's a great summary.
And it leaves us with some really big questions. If our reality is just this filtered version, what is the nature of that lost information? What wonders are hidden in the depths of the implicate topos?
It's exciting to think about, isn't it?
Absolutely. So, listeners, I hope this deep dive has sparked your curiosity. What might we be missing from this bigger picture of reality? Think about that, explore it, and let your imagination run wild.
I think that's a perfect note to end on.
It is. Thanks for joining us on the deep dive. Until next time, keep exploring.